Hello everyone. So welcome to my channel. Today we are going to do TP challenge 5th day question, and this question is basically uncrossed lines. And this question is like these days we are doing question based on longest common subsequence. So this question is also based on the same pattern only. So you would be amazed to see that how it is similar to longest common subsequence. So stay tuned till the end for the same, and let us start with the question. So here comes the part. You are given two integer arrays nums1 and nums2. We write the integer of nums1 and nums2 in order they are given on separate horizontal lines. Okay. And next thing which is given to us is we may draw connecting lines, a straight line connecting two numbers nums1 I and nums2 j, such that. So here these conditions only take this question away from the else yes, but at the end when you would be doing about some dry run of the test cases, then you will figure it out that it is about else yes only. So here nums1 of I equals to nums2 of j. This is the condition. Then only we can draw a straight line, and the other condition is the line we draw does not intersect any other connecting non-horizontal line. So here two conditions are given, that two arrays are given to us, and in those various integers are given to us, and we can connect a line from one integer to other if and only if they are same. If they are not same, then we can't draw a line between them. And another thing is that when these two integers we are joining them, and when we are joining other two integers which are similar, then both of them, those lines shouldn't be connected. Means they shouldn't intersect each other while connecting the lines. And then next, note that a connecting line cannot intersect even at the end point, that is, each number can only belong to one connecting line, and then return the maximum number of connecting lines we can draw in this way. So here you can see that 1, 1, it is same, right? So that's why we can draw a straight line to the same. 4, 4 are the same, so we can draw another straight line. But here you can see we can also draw a line between 2 and 2, but there the condition would be violated, this particular condition. The line we draw does not intersect other connecting non-horizontal line. So here 4, 4 was already connected, right? So when we connect 2, 2 also there, so at that moment it will intersect this 4, 4, and just because of that only we can't draw 2, 2, right? So this is a thing which we are required to figure it out here, that how much lines we can draw without intersecting any other connecting lines. So here you can see that and so that's the reason we are just giving this 2 as the answer. So now comes the part that we can draw 2 uncrossed lines as in the diagram. We cannot draw 3 uncrossed lines because the line from this particular 2, 2 would intersect this particular line. That's the thing. So in this next example, let me draw on the board, and there you can see that how it goes on. So here you can see this is that particular example which we were doing, right? So here if we check for the longest common subsequence, how we will be checking? 1, 1 is common, right? So we will take it. 2 and 4 are not common, right? Okay, then let us move in the first one to the 4th, and now we got that both of them are equal, right? So but this is now exhausted, right? So till now we got 2, and here also 2, so and then we are returning 2. So again in this particular we check, here you can see that 5, 1, 2, 5, and then 5, then 1, then 2, right? So these contribute to longest common subsequence. And in the other example 1, 3, 7, 1, 7, 5, here you can clearly see that 1, 1 are matching, then 3 is nowhere there, then 7 is nowhere there, right? 9 and 2 are nowhere there, but then 1 is basically matching with this one, right? So here you will be returning 2 as the answer. That is, the longest common subsequence for this particular would be 2. So this is the thing which we are required to do in this particular question. You can clearly see from this examples only that we are checking for the common ones who are contributing to the longest subsequence. And here we can clearly see that we are figuring out the longest common subsequence, as in the subsequence we maintain relative position, although there could be instances when whole string becomes subsequent. So this is the thing which we are doing here. Now comes the next part. Okay, it has just 1 minute. So now the question boils down to LCS. So whenever we are required to do the LCS question, how we proceed with the same. So one more thing which was left in this question was seeking the time constraints, right? So here you can see the constraints are the length of the nums array is basically 500 and each character could go up to 2000. Means basically each integer which is being given to us, at max it can go up to 2000. But we are just comparing them, right? Not adding them up, right? So that's why this particular constraint doesn't matter to us, but this matters to us because this will be contributing towards that time complexity of the solution. So according to this, as it is 10 raised to power 2, we can go ahead with the 10 raised to power 4 also, and even 10 raised to power 6 also we can go. Till then there won't be any TLE, right? So order of n solution would also work, order of n log n solution would also work, and even the if we say that order of n square, that will also work here. So these are the range of the solutions which could work here. So let us first figure out, as we had already figured out that this question is about LCS, right? So what we would be doing now is, we will try to first figure out about the recurrence relation of the same, and then how to memorize it, and then bottom up DP. So let us go ahead with the same, then after that I'll show you the code walkthrough for the same. Okay, so yeah, let's go. So first comes the part about the recursive solution. So for the recursive solution, there are three things which we need to consider. One is base case, other is options, and the third is recurrence relation. But in all these three, first we are required to figure out the options which are given to us. So what options we are having? See, you can clearly see either we can choose this particular one or we can't choose this particular one, so we will be choosing this particular one. I mean to say that in this whole particular not word, we would be given with string, I guess. Means whatsoever is given to us, string or vector of integer, whatsoever is given to us. So either we will be choosing from this particular nums, right, or we would be choosing from this particular. This is the options which are being given to us, right? Means either we will include it or we will exclude it. This is the thing which we will be doing, right? So two options are there. So according to that only we would be making our recurrence relation. So in this recurrence relation, how we would be proceeding ahead is, as per the condition, there it was given that if both of them are equal, right? So if both of them are equal, then only we can draw a line between them, right? So if both of them are equal, then we will add 1 to our selection, else we would be checking that whatsoever answer we get maximum, and by maximum we are required to return, because in the question they had stated us that we are required to return the maximum number of connecting lines, right? So that's why we are required to return maximum. So next thing is, that's why if they are equal, then we would be adding 1, because then we can draw a line between them and we will return the function as it is. Else we will return maximum of either choosing the first one or choosing the second one. So this is the thing which we would be doing here. Now comes the next part, that what would be the base case of the solution. So you can see that if a particular here the sizes are unequal, right? So if either of them get exhausted at the first, right? If this second one get exhausted, that is if n becomes less than or equal to 0, right? Then in that criteria we would be returning 0, because after that we won't be having any match. So that's why we will be returning 0 here. So that's why our base case is basically n less than equal to 0 or m less than equal to 0. So we are required to return 0. And how we are required to memorize this particular solution? Because there are two variable paths. One is for the nums1 and other one is for the nums2. So that's why we would be using a 2D data structure for storing our variable parts in the same, and then I'll show you that how we can come up with the same. And one more thing, the time complexity. So So the time complexity of the same is order of 2 raised to power n for the first one, m for the second one, n into m, and the space complexity is basically order of n plus m, and here also plus. So this would be the time complexity and space complexity for the recursive solution, and for the memoized part it would be n into m, and for the space complexity that would be also n into m. And now comes the part about the bottom-up solution. So as I earlier told that how we go ahead with the bottom-up solution is that whatever function was here, right, we will directly make into a DP, means basically a table. This would indicate as a vector and this will also indicate as a vector. We will convert this function into a vector and one would be as it is, and we will be, the way we were assigning the memoirs to a particular vector or any other data structure, like that only we will be assigning this to that. And the test cases would be handled by filling up a table in such a manner, like keeping one extra row, one extra column, where all the zeros would be filled like for this particular base case, and this is how we will be able to transform this particular recursive solution into bottom-up DP. So now comes the next part, that how the bottom-up DP is like. So here the state of the bottom-up DP is basically DP of mn, and transition is if num1 of n minus 1 equals to nums2 of m minus 1, then dp of nm equals to 1 plus dp of n minus 1 m minus 1. Else dp of nm equals to maximum of either we will be choosing with the first one or we will be choosing with the second one. So this is how our bottom-up solution would be like, and the time complexity would be order of n into m, and the space complexity would be order of n into m. So these are the solution which we can come up with for this particular. Basically in the interview perspective, they will be asking us from the brute force to the what we say at the most advanced version, means most optimized version. So like this you can come up in the interview for the same. And from interviews I just recall that some of the students were asking about a structured course where they could get one-on-one mentorship or doubt clearance and so on. So you could directly head over to the Nutanix school, whose description is basically given in the description of this particular video, and even the link to the website is also given there. You could directly head over to that and get all the details which is being there. So this was one of the recommendations from my side for, and so this was all for this particular question. Now comes the part about the code walkthrough. So let me show you about the code, because that is also important. Without that, question is incomplete. So here comes the part for coding, and here this is. So first is this one, which is our recursive solution. So here you can see that in this particular, we are basically making a function solve, and in that we are passing nums1 and nums2 and passing the sizes of the both, and then what we are doing is we are directly taking three options, because we are having either we will be skipping both at the same time, or we will be choosing one at a time, or we will be choosing the other at a time, right? So that's why we are having three options. And then here first I have taken about the base case, that is n is less than equal to 0 or m is less than equal to 0, then we will be returning 0, because if either of them get exhausted, right, then in that particular scenario we are required to return 0. And the next part comes up that if both of them are equal, then we will be returning 1 plus solve of nums1, num2, n minus 1, m minus 1. Basically, we have selected because both of them are equal, and then we will be moving ahead with the others. And now comes the next part. My cursor is not moving. Okay. So now comes the next part. Option 1, that either we would be choosing the second one, that is m minus 1, or we would be choosing the first one, that is n minus 1, and then we will be returning maximum out of both. So this is, we are going ahead in our else part, and this was about the recursive solution. Now comes the part about the memoization. So in memoization, we have taken a DP of 501, 501 just because of this thing which is given to us, that is we are having at max 500 length correct elements in a nums1 and nums2, so that's why just taken one extra just for handling up the base case. And let us first start from here. here we are basically taking our DP and giving it this size and even initializing it all with -1, and then we are passing the same way we were passing in our previous recursive, and here is the same way our base case, and then here is the that if it is not -1, because earlier we had initialized it with -1, right? So if it is not -1, then surely there would be a sub case which is being stored in the same, right? So that's why at that particular moment, if it is not -1, then we will be returning the same. Else we will be going ahead with our solution. We will be checking that if at this particular moment nums of n-1 equals to nums of n-1, means at this particular moment both are equal, then we will be directly adding 1 and calling our function, and whatsoever result would be, we will be assigning that to this particular DP of n-1, m-1. So that is the case here. Else we will be checking for our options, and then we will be getting the maximum out of option 1 and option 2 and assigning to a DP of n-1, m-1. And at the end, we will be returning this particular, that is return DP of n-1, m-1 equals to maximum of option 1, option 2 and option 3. So this is the thing which we would be doing here. And now comes the next part. That is this particular bottom-up DP. So here we are at the starting only taking up this size, and then here this is that 2D vector in which we have initialized with 0. And why we have initialized the 0? So that row 1 and column 1 became 0 only, and further rows would be filled up as per we will be moving ahead. So that's why even if we make whole our DP vector of vector as 0, then also it's fine. So here comes the part for the 2D, not 2D, but nested loops, and here we can check that if both of them are equal, the way we were doing in our recursive and memoised, then we will be assigning to our DP of ij equals to DP of i-1, j-1 plus 1. Else we would be checking maximum out of both the cases, and at the end we will be returning a state that is DP of mn. So this was all for this particular question. If you have any doubt, you could comment it down. And if you like the explanation, or if you like the whole video, then surely please do like, subscribe to my channel and do share it. Thank you.